We're looking at integrating x sine inverse of x dx, and we can go with two methodology, taking uv directly over here or substitute and then use it. So I'll go the other way around because that is one more method. So if you guys get to understand that, I think it will help you get a different perspective on things. So if I take t as sine inverse of x, so I want an expression for x2, so that would be sine of t is equal to x. Agree? So let me change the color. Sine of t is equal to x then. Then if I differentiate this, this would be cos of t dt is equal to dx. So we have all the required expression. So your I will change to, this is sine of t, this is t, and this is cos of t dt. Now we can integrate it. So we're going to call, okay, so this is where we have to think. If I call u as t and v as sine t dt, is this okay? Well, sine t dt is sine of 2t by 2, so yeah, it makes sense. So this is convenient. So if I differentiate this, I'll get 1, and if I integrate this, I'll get 1 by 2 integration of sine, okay, this is t by the way, sine 2t dt, and this would be minus cos of 2t by 4. Okay, why 4? So if I differentiate cos 2t, I'll get a negative, so this becomes positive, that's good. Then this becomes sine 2t. As per chain rule, I have to differentiate 2t again, so I'll get a 2. So 2 and 4 will get cancelled, and so on and so forth, right? If I differentiate this, I'll get a negative of negative sine 2t into 2 by 4. So this will result in the same expression, and that's how you think of it, guys. Okay, so differentiating this with respect to t will fetch us this, and that's the same as, right? Okay, moving on. So we'll have to write the formula first. So uv dx or dt in this case will be equal to u integration of v dt minus integration of u prime integration of v dt dt. So I is equal to, so here what is it, u is t, but that is negative, so t cos of 2t by 4 minus integration of derivative of u is 1 into, so minus of minus becomes plus, cos of 2t by 4 dt, right? And at last again integrating this would be minus t by 4 cos of 2t plus 1 by 8 sine of 2t plus a constant. Again, all you have to do is think of differentiating this, see to that you get back this. If you have any confusion, if you do that process, you will get to see that you need a 2 in the denominator. So 1 by 4 into 1 by 2 is 1 by 8. Right, guys? So substituting the value of t, or before that, see, t as a value is sine inverse of x. Sine of t is x. So I have to express all of this in terms of sine of t. Expressing in terms of sine t. So let's do it. Minus t by 4 into this would be minus 1 minus 2 sine square t plus 1 by 8. Let me write it below, 1 by 8. this would be 2 sine of t square root of 1 minus cos squared t plus c. So on substituting, I'll get, so t is sine inverse of x by 4, and this is 1 minus 2 x square, plus this would be 1 4 so 1 by 4. This would be x and square root of 1 minus, my bad, this is sine square t, x square plus a constant, right? So I hope there's no confusion. Sine 2t is 2 sine t into cos t. Cos, I am writing it as square root of 1 minus sine square t. So let me write it off actually. This is nothing but 2 sine x or sine t cos t, and cos t in turn is square root of 1 minus sine square t. In the exam, you should be able to jump to this point directly, right? And all of this formula should be very familiar. So again, we keep going back to same set of formulas and same set of ideas. So this sheet is so important. You guys have to keep going back and forth, right? So plenty of usage over here. Okay, so that looks like your answer. Just let me verify it. Okay, looks correct. Yeah. Okay, now pause and copy all of this. Understand all of this as well.